Hello, welcome back. My name is Calcinez, and what we're gonna do is review of electricity on the 3D printers. So right now, there's a big confusion, questions about how you gonna power this from a residential building to a commercial building, or a regular home onto a company's building. So there's electricity out there that it can be powered out onto this printer. Yes, that's true, and that the cable it can actually withstand, which is this guy right here, about 300 volts. However, will it work the same thing as a residential building? So each location or buildings has to go up to about either 120 volts to about roughly 224 volts. As this building from here, same concept, it's about 120 volts, or right now I'm measuring is about 121. So that's in between the average of how much power is being put into it right now. But how's it going to work out with the 3D printers at the home? Because again, I did explain that this cord does power up to about 300 volts. So one thing we can actually look into is the power source in the back. So I'm going to unplug this guy right here, this USB port. And what we're going to do is just rotate it backwards and see the back of it. So don't worry if you can't see the letterings, don't worry. I can actually input another image. Grab this one. Okay. Now it gives us the information about the power system. So on here, if I can find it, it's kind of very small font here. And as you can see right at this section right here, it gives us about 100 to 240 volts as predicted. And the other one for amperage is going to be about 0.9 to 0.45 amps. And the other one in hertz is going to be about 50 to 60 hertz. So what does that mean on those electricity? I don't know. That's the biggest question. I don't know because I'm not an electrician and I'm not into the electrical engineering, but I will try my best to actually convert these ones into the how it makes sense. But the biggest one is that how much is going to cost through, how much is going to be put out from the commercial building to the residential building. So along the way, there'll be two different ways right here. Right now, the other day, we're going to write this down here on your notes. It could be writing down what your measurement is, what's your date, how long did it take your printing hours, and that. See, we can actually adjust it into the Excel file. I'm gonna make some the analysis of the chart and see how that one goes. So, and also too as well, how do we measure the electricity? Well, there's one way you can do it is by multimeter. The multimeter is basically a voltage device or electrical device to measure the electricity. Same concept will be voltage, volts, amp, watts, and I believe there's some other ones too as well. I think it was ohms, I believe. So again, I'm still new to this concept, or still trying to trying to understand the electricity concept too as well. So one way you could do it is by either a voltmeter. So kind of be careful. You have to use an adult advisor, or if you had a specialist to actually measure your outlet from the outlet wall, which it could be this guy right here, which is this outlet, and that's going to be attached into your wall. Or you can try is if you're near in the New Mexico area, if you have a Harbor Freight store or any store of Home Depot or Walmart, if they have this device. Another one is this right here, the measuring device right here, which is the kilowatt, and that's P3 model. It doesn't matter which model it is as long as it reads your voltage. So right now, as I plug this in onto the outlet cord right here, and this cord is connected to the outlet wall itself, and right now it's measuring 121 volts and 0.2 because right now it's fluctuating up and down, and this is where it comes in right now. Amperage, once I press it into amperage, nothing's going on right now because there's no powers being moved. Watts, same thing. Hertz, 60 hertz right now, and kilowatt per hour, which same thing again. The timing is varies differently on how it's being used every now and then. So okay, now then, how do you know and how you measure this one? Basically, it's just simple. The concept, since we have this measuring device, if you can actually get this this measuring tool, you can actually plug into the plug it into the printer like so. So plug this in, outlet wall, plug in your electricity in, and that's it. So that's all you can do. Now that what you could do is once you're printing out any type of devices. So the other day we've been doing one for the actual self on the printer itself. So as the first one, it's gonna be nothing. That's good news. The time I'll probably fix that one every now and then because I don't know how the time works on this meter. But same concept is just going to be the voltage, amp, watts. That's what we're going to look into, and still going to actually input that one onto how much of the commercial building can actually take out. So, and the printed cube, we did that one the other day, which is this little guy right here. We print this cube as a test, and it gives us the different type of voltage readings of how it's going to fluctuate up and down. Next one is the keychain, or that little Marvin keychain, which is this little guy right here. This has a lot more different orientation and different objects on the shapes, so that one gives it a little more different power. That's good news of the actual printing itself. So we did two of them. I forgot to put this on the print cube, which is the base plate, because right now it slowed the power down, and after that, once it goes faster, it begins to print out right away quickly. So same concept as the Marvin key. Right now we did one for the print bed, which is just by the platform, which is the removable support, and the print itself, which is the Marvin. Halfway's how it's being printed at 50%, and now it's to see how everything else will go on to. Okay. Now the next one is this. How does this machine actually power up everything else on this device? So right now I'm going to discuss this right here is about all the features onto here. So mainly the first one that actually did actually, let's go to my next printer, which it'll explain a lot more onto that one. So okay, so welcome back. Now then, this is the actual printer that I have right here that does explain a lot more further detail. So this is the actual first printers that is being used as the same frames. So it has the frame, motors, the bed support, same concept. This one right now is the Monoprice company. So they actually use the same design off of another company as well, but in their own different design to see how it functions. But the main difference is the G code and the code itself within the main board, or the motherboard too as well. So how does this actually relate to the MakerBot? Well, first off is that we have the same concept as the motors. So we have one stepper motor back here, or actually two stepper motors back here, so that's two of them. A third stepper motor, which is this guy right here that extrude the, or actually pull in the extrusion of the filament inside of it. We have the fan to cool down the filament while it's getting hot. So once it enters the printing bed right here, it will cool down right away. We also do as well, we have is another motor back here, which is another stepper motor. So we have is 1, 2, 3, 4 stepper motors. So that one moves all the motion around that actually creates your 3D printed part. So for example, it'll be this cat right here. So 3D print this guy. So it'll print everything else in all the directions. So you're going back and forth, left and right, up. Actually, the motors itself is gonna go upward all the way on top. It never goes down because we want to build this up on the printing process. So that's how it works right now. Then at the same time, the spool, which is the filament, is being pulled onto the motor, which is the same concept as the MakerBot on the nozzle itself. It'll print out the motor too as well, same thing, and it'll draw in the filament with inside the nozzle. I'm gonna go get a demonstration just in case. Okay, so this looks like from the demonstration of the nozzle itself, or this is just the spare part that has already been broken. But this is a demonstration of how it looks right here. So same concept, this one right here, this little circle, it has the motor inside of it. So there's a small motor inside that draws the filament inside here and being pulled and inside this nozzle and into the heated extruder. Now, same concept as this one, except this is a little more larger and a different gear mechanism from the inside that can be changed inside. Then we have these two cooling fans because it'll prevent the heating element from overheating, but we don't want to overheat it, so it'll turn off every now and then. So another one is the heating element. So there's a heating element that's very small inside, and that heating element is the one that heats up your filament. And the heating element is like this right here. Make it this guy. Is this little guy. So that's the heating element. It may look small into your eyes, but this little guy heats up really high, so about 400 to 500 Fahrenheit, but depends on the description of what it's being used for. So this is very small for any small project and small machineries. There is different type of heating elements, but that will be explained later on. Okay, And at that same concept as this one too as well from the make on the motor price. So there's these little attachments on these cables. So this is attached to the stepper motor. It'll attach to these two cables from the fans and the heating element, and these ones other ones is attached to these other stepper motors. Same concept as this one right here. This one has those little pins, so this one connects to the either the motor, the heating element, and then the readings inside of this one. But this one is a lot more different because this is much more advanced, but there's a little small microchip inside of it, so that one gonna leave that alone. But this one right here, it's just basically cables. You just reattach it to replace any components. So this is the reason why these ones are much better from the um, other companies, because they do have, if you want to learn on your own, that's a good thing too as well. If you want to learn about 3D printers, you can actually reattach these motors and replace it to a newer accessories, and have to replace those again. So same concept. But the biggest one of all is this little guy this guy right here. So this one right here has the main board inside of it, and this one has a larger power output than the other MakerBot, or the MakerBot. Well, the MakerBot does have the same power input too as well inside of it, but yeah, same thing. Power sources, same thing too as well, about 120 to 240. So same voltage situation now. And the main board is the biggest one that controls everything else onto the power source. So now then, the power, how it's being pulled in, it depends on your printing. So it doesn't mean that it'll consume all the power in. Well, it kind of does, but it depends how what your part is. So for example, if you want to print the cube like we saw previously, that brings in a little more power because it actually is a square base, but it depends on what it looks like from the inside of the filament. For example, this cat right here, this cat has a lot of geometry into it and has a lot more of the inside, so that way it'll print from the inside all the way to repeat itself over and over and over again, and it's going to keep going all the way up to the layers, but it'll fluctuate on the power, how it's being moved around. So it'll pause, it'll slow down, then it'll speed up again, slow down, speed, slow, speed, slow, fast, slow, fast. You get the idea. But it depends on this right here too as well. What happens if it stops the motor? So if there's like a gap right here, it'll stop right there, go over here and repeat the same spot, stop, go over here, and same thing as go back and forth, back and forth. And that does affect the power itself too as well. And also, so there's another one it'll affect is the infill. So it depends like what type of infill you put inside the printer. So for example, this other same cat, but it's a yellow one. As you can see from the inside, you notice that those infills inside has those triangular squares. That's how it affects the inside too as well, to actually stabilize or to make the part much more structured. So it depends like what type of infill you put inside of it, and that will affect the power. It's going to affect the motor too as well. So again, it will move around on itself and it will affect the power, but it ranges up and down. So it goes up and down every once in a while. So it has to stop, cool down, reheat, cool down, stop again, speed, slow down, fast. It does the whole entire thing because the main motherboard is to control everything else, and it depends on the file type of the STL that's being transferred onto the G code, and the G code will tell the main board to control all of these ones to actually print your part onto that one. So I hope that does make sense. So if you're a little bit confused story, you can comment down below, and that will explain that little concept a little more further ahead, and while we're learning along the way. So I hope that does break down the process of the MakerBot and this monoprice printer, because again, this one is the same concept as the MakerBot, but a lot more different on how it's being printed out. Okay. Okay, so on the MakerBot, now the same concept, same main board, but different slicing and different coating. So on the monoprice, they use a different slicer, which is the Creo. Mainly people don't want to use that old model or the old software, because I just found that out about a year ago that one software slicer is very old, and that's not going to be used every now and then, because again, the settings on that one, it doesn't work on these type of printers. So that way it's not really supportive and very appropriate for it to actually print it out. For the MakerBot, the software that they created on their slicer, which is the MakerBot slicer, That one's a little more different, and they actually have a different settings for that one, and they actually program that one a little more different, but a lot more different speed up. So whenever you're printing your part, people want to ask like, can you print this part faster and quicker? Can you print the parts in multiple items like this way right here? So if I was gonna print like two of them at a time, if I want to print both of them on the same plate, it can do that. Same concept with the other printers too as well, same thing. But again, it depends on the slicer and the G code, how it's being set up and how it's being used onto the printers. Because again, each printers is not always the same thing because it'll vary differently and how it's being set up in its own way. So, and also too as well, from the MakerBot, it prints differently on the different materials. So for example, the Replicator Plus and the Mini, the filament types they use is the PLA, ABS, and I hope PETG. I have to look into that one. That's how far it can go. Because again, this is just for educational purpose and for a beginner's 3D printer. If you're like interested in the 3D printing, do some demonstration, modeling, prototype, and some fun activities. So that's how it's supposed to look like. And also too as well, it depends on the what type of resolution you actually print out or the quality how it's being printed. So for example, like I show you, there's this guy here, the cube. You can actually print out that much how detailed it is. Or from my other printer, which is the Monoprice that I got, it can actually print out this good quality print right here. You got to see the filament sizes, how it's being oriented. So as you can see, and that way it'll print this type of this texture on the filament sizes. And also I'm gonna do comparison too as well. As you can see, both of them right here, from the nozzles, or actually right here, there we go. From the layer heights too as well, it varies differently too as well how well the quality looks like. So it depends how you actually set up from your settings. So hopefully that covers up the entire Electricity. Right now, I will post up the Excel to show you the difference, like how it's being printed out. Right now we did two of them, which is the Cube and the Marvin. I will continue this on with the other prints that I showed you before, which is the test print for the entire function to see if it does print out, and the Bendy boat to see, or Benchy I think it was, Benchy the boat, how well that will print out, and go from there and see how the power fluctuate. And I'll show you that one next one. Okay.